This is a tutorial on the standard form of quadratic equations. A quadratic equation is just an equation that we can write in this form. Here we have ax squared plus bx plus c, where a and b are just coefficients and c is a constant term. So these are just numbers. And notice that a cannot equal 0. So a quadratic equation then is just an equation with this square term on it. Now each one of these terms in the quadratic equation has a name. Our first term here with the square is called our quadratic term. Our term with just an x, or x to the first power, this term is our linear term. And notice most linear equations are y is equal to mx plus b, say. Notice we have an x to the first power. So that's why this is called the linear term. And then our last term is just our constant term, or it's the number that's added on the end. So now that we know what a quadratic equation is, let's see how we graph it. Well, the easiest way is just like graphing any other equation. You plug in values for x, and you solve for your function values, or your y values. And once you have all these ordered pairs, then you can use them to graph your function. So here we're given several values of x, so let's plug them into our equation and solve for y, or solve for f of x. The first one is -4, so if we plug that in, we'll have a -4 squared plus 4 times -4 plus 4. And again, I'm just plugging -4 in for x. -4 squared is a positive 16. 4 times a -4 is a -16, and then plus 4. 16 plus -16 plus 4 is just 4. So our function value, or our y value, when x is -4, is a positive 4. Now we'll plug in -3 for x. We get -3 squared plus 4 times -3 plus 4 again. -3 squared is a positive 9. 4 times -3 is a -12, and then plus 4. 9 minus 12 plus 4 is a positive 1. So our function value then, when x is equal to -3, is a positive 1. Now we'll plug in -2. We have a -2 squared plus 4 times -2 plus 4. -2 squared is a positive 4. 4 times -2 is a -8, and then plus 4. 4 minus 8 plus 4 is equal to 0. So at -2, our function value is equal to 0. Next we plug in a -1. -1 squared plus 4 times -1 plus 4. Again, I just plugged in -1 for x. -1 squared is a positive 1. 4 times -1 is a -4, and then plus 4. So 1 plus -4 plus 4 is just 1. So our function value, when x is equal to -1, is just a positive 1. Now if we plug in 0, we'll get 0 squared plus 4 times 0 plus 4. 0 squared is 0. 4 times 0 is 0. So this is just equal to 4. So if we plug in 0 for x, we'll get 4 for f of x, or for y. And then lastly, we plug in a positive 1. We'll get 1 squared plus 4 times 1 plus 4. 1 squared is 1. 4 times 1 is a positive 4, and then plus 4 again. This is equal to 9. So when x is 1, our function is equal to 9. So now we have these 6 ordered pairs, and let's plot them on our axis. We have a -4, positive 4. So -4, positive 4 is right there. -3, 1 is right there. -2, 0 is right there. -1, 1 is right there. 0, 4 is right there. And then 1, 9 is right about there. If we connect these with a smooth curve, it's going to look something like this. Now notice this U shape that we have. This shape is called a parabola. All graphs of quadratic equations or quadratic functions are in the shape of a parabola. They will all make a U-shaped graph. There's some important things we need to recognize on this U-shaped graph. Down here, we have the lowest point on our graph. Every y value on this graph is higher than this point. So we call this point the vertex. And if we draw a vertical line through that vertex, like this, we can see that this graph is symmetrical on both sides of this dotted line. So we would call this our axis of symmetry. Well, now that we know what an axis of symmetry and our vertex is, let's see if we can find them from our equation. Well, first off, we have ax squared plus bx plus c. The easiest thing to find is our y-intercept. Remember, y-intercepts occur when x is equal to 0. And if we plug in 0 for x, we'll have a times 0 squared plus b times 0 plus c. Well, 0 squared is 0, and a times 0 is 0, and b times 0 is 0. So c, right away, is our y-intercept. Now, if you want to find the axis of symmetry in the vertex, you use this formula right here. X is equal to negative b over 2a. This is the equation for our axis of symmetry. Remember, the axis of symmetry is a vertical line. So it's going to have the equation x is equal to some number. The vertex occurs on that axis of symmetry, so this would be the x value for our vertex. And once we have our x value, we would have to plug it back into our equation to find our y value. So this is the x coordinate of our vertex. So let's go back to our original graph. Here we have f of x is equal to x squared plus 4x plus 4. Our y-intercept then should occur at 0, 4. Because that's our constant term, and that's just supposed to be our y-intercept. So if we go down here, we can see it does indeed occur at 0, 4. Now our axis of symmetry occurs on the line x is equal to negative b over 2a. Well, our b is 4 and our a is 1. So this should occur at negative 4 over 2 times 1, or x is equal to negative 2. So let's draw the line x is equal to negative 2. And we can see, indeed, it does go through the lowest point of our graph. And the graph is symmetrical on either side of that line. So lastly, we need to find our vertex. Well, we know our vertex occurs on that line. So negative 2 is the x-coordinate of our vertex. So if we plug in negative 2 into our equation, we'll have a negative 2 squared plus 4 times negative 2 plus 4. Negative 2 squared is 4. 4 times a negative 2 is negative 8 plus 4. So our y-coordinate then should be 0. So our vertex should occur at negative 2, 0. Well, it does. Negative 2, 0 would be right there. So this is the vertex of our equation. Now the last thing we have to talk about are maximum and minimum values. Here we're given the function negative 2x squared plus x plus 1 and its graph. And then our other function is f of x is equal to 2x squared minus x minus 1. And again, we're given its graph. Notice the only thing different between these two equations is one of them is multiplied by negative 1. But they have the same axis of symmetry, but other than that, they're very different. They have different vertexes, and one goes to negative infinity in the y direction, and the other one goes to positive infinity in the y direction. Well, this is because of our a term. If our a term, or our first coefficient on the quadratic term, is negative, then your quadratic function, or the parabola, will point downward, or will go to negative infinity in the y direction. If your coefficient on the quadratic term, or your a term, is positive, then your quadratic function will go on to positive infinity in the y direction. Well, if you have a negative a term, or your coefficient on your quadratic term is negative, and the graph continues down to negative infinity in the y direction, that makes your vertex then the maximum value of the function. There are no other points on this function that have a higher y value, so this is your maximum. And then if you have a positive coefficient on your quadratic term, or your a is positive, that makes your vertex then a minimum value. Every y value on this function is greater than your vertex. The vertex has the lowest y value, so it is the minimum of your quadratic function. And you can find these y values just by solving for your vertex. And that completes the tutorial on standard form of quadratic equations.